All right, I wanted to give you another example, an example to look at of calculating these things. Now, in the last example, I kind of scaffold you through the process of what's going on behind the scenes. But if I gave you a function, for instance, like in this example, I give you like f of x equals the square root of x plus 1, and I want you to estimate f prime of 3, you don't have to go through a, b, and c. At this point, we know the instantaneous rate of change is the basically the average rate of change over shorter and shorter intervals. And so what we can do to find f prime of 3 is immediately say, okay, well, I'm going to use my average rate of change, and I'm just going to pick from, like, let's say x equals 3 to x equals I'm going to use the interval of width 0.001. And so I'll go from 3 to 3.001. And notice if I were to put that on the number line, 3 will be over here, 3.0001. And so this will be like a right hand derivative. But in either case, that I will use my average rate of change formula. So f of 3.001 minus f of 3 all over 3.001 minus 3. I could go and plug these values into my function, right? I'm going to write it up here. That'll be the square root of 3.001 plus 1 when I plug in f of 3.001 minus, I'll plug in 3 over 3.000001 minus 3. And that equals approximately, I did that in my calculator earlier, 0.249984377. Okay? Remember, this was a right-hand derivative. If I want it to come from the left of 3, I can use, let's say, I know I'm going to end at x equals 3, and let's say I still want to do an interval of width 0.001. Well, I'll do 3 minus 0.001, which is 2.999. And so when I plug this into my average rate of change formula, I'm going to do f of 3 minus f of 2.999 over 3 minus 2.999. And so I put that in my calculator. After I plug in 3 into my function, then I'll go through the process of plugging in 2.999. And when I do that, I'm going to get 0.250015627. And then an alternative approach is to kind of come through the center, right? Where I go and I say, well, I don't want to use my endpoint. I want my value of that I'm trying to find, my instantaneous rate of change. I want that to not be on the endpoint, but I want the interval to consume that value. So if I look at my number line and if I still want to use 0.01, well, I'll divide 0.001 by 2. That's that 0.0005. And so I'll go up 0.0005, which is 3.0005, and I'll go below and subtract 0.0005, and I'll get 2.9995. And then that way, if I want to do my average rate of change, these values are the values that I'll use. And so my f prime of 3 will come from doing f of 3.0005 minus f of 2.9995 all over those x values subtracted from each other. And I did that in my calculator, and I actually got 0.25. And what you'll find out is that most of the time, this centered version is the average of these two here. Okay? This one here. But you don't have to go through all this process. If you were to stop here, this is your approximation. You can see that this is a number that's very close to 0.25. If you were to do the left one, you can see that this is a number that's very close to 0.25. And when you average them together, or if you go kind of give you a centered derivative, then you'll see that you'll get that 0.25. And it is, in fact, true that the derivative at x equals 3 of this function is 0.25. That's it for these videos.